Hello everyone, this is Ivan and today we're going to learn about regular expression or regex. What are they? You can think of them as a pattern definition for a text search. So if you have a big string and you want to find a little substring, you can define a pattern and find it later. The most common use cases for the regular expressions are, as I mentioned, search and validation. For example, is the password I'm entering when I'm registering my account strong enough or not? And today we're going to learn all about that. For today's demo, I'm using the website regex101.com and it looks like that. You enter your regular expression here, you have your test string here, and you have your match results over there. Before we go, I want to mention that regular expressions are defined in a standard, but different languages are having different implementation of that. Therefore, the regular expression you write in JavaScript might not work in Python or .NET or any other programming language. You always need to double check that when you search for regexp in the internet. Don't search for regexp in the internet. Today I'm going to use a JavaScript flavor. Let's start with something very simple. Everything in the regular expression is either a literal character or a metacharacter. Literal character means it matches it literally. So if I have a Frodo Baggins as my string, I can search for Frodo literally and I will match it over here. If we add a meta character, for example, I will add the colon and there's no problem here, but if I add the bracket, now bracket is a meta character, so it breaks the expression. And you could fix that by escaping it, so I can convert meta character into literal character by escaping it. Examples of meta characters are dot, brackets, asterisk, and some other character. Next one is boolean or. Imagine that we have a Frodo Baggins or Bilbo Baggins and we kind of don't mind either of them, we want to find both. So you could do the pipe Bilbo and you can see that that's our regular expression and it matches Frodo. If I delete the Frodo, I find Bilbo, no problem. To better understand what's going on, I recommend you to use capturing groups. This is just when you put a block of regexp into the brackets, and you can see that it shows me that there is a group 1 where we matched Bilbo. It just makes everything easier when you start writing slightly more complex regular expressions. You probably noticed that despite we were talking about Frodo or Bilbo, Bilbo didn't match when the Frodo was here. So to fix that, we need to talk about the modifiers. So the modifiers is things that apply to this whole regexp to make it more flexible, let's say. And one of them is a global modifier, and let's enable it and see what it changes. So the global modifier means it will not return after this first match. So if I enable that, it will match Frodo, and then it will continue doing the search in the string to see if it can match more. So we now match both Frodo and Bilbo. Now there are many modifiers and the most useful ones are global, multiline, and case insensitive. If we add a lowercase Bilbo, you can see that it's not matching because we have capital B here, and you can fix that by adding this modifier. And you can see that now Bilbo matches. To demo the multiline modifier, I need to introduce two more meta characters. So they are the circumflex or symbol, or I call it a cap, like a roof cap, because it's easier to remember, and the end of the string character. So if you see, if I add the beginning of the string, now only this Frodo matches, because the regexp engine thinks of the whole text here as a one string. So if I enable the multiline, now each of the new lines are going to be considered an input and going to be tested against this regular expression. So now we match this, this, and that. The same logic applies for the end of the string. I can say, okay, where the Frodo or Bilbo are at the end. Now we're going to talk about the character sets or the character classes. Imagine that we were searching for the Gandalf the Grey and we found it Happy Life. However, we later discovered that some other countries use the different spelling for the word grey, and we are shocked and we want to fix that by modifying our regex. So the syntax for that is a square bracket and then the literal set of characters inside that you want to match. So you can say give me A or E and any of them will match. And you can see that both of them are now matching. You could achieve the similar thing by using the negation symbol. In this case, it's circumflex. And you could say, give me everyone that is not all. And you see that we have the same result on not A. Another way of doing the character set is specifying the range. You could specify the range for the letters or the digits as an example. So let's do it right here. So we can replace this and say, give me all of them which starts from A to G. So we found the Gandalf and the Bandalf. I can add the lowercase ones. Let's say I will also say A to G, lowercase. Or I can say maybe 3 to 9. And I found that one, but not this one. One more concept in the regular expressions is quantifiers. And before we talk about them, let's look at another meta character that we were going to use. It's a dot. Dot means a wildcard. It literally means any symbol. So let's search for something like, maybe we're searching for SA and then we search for 5 characters after that. And maybe we found out that the Sauron is going to be very upset that we didn't find him. And now we will talk about the character which means 0 or 1. It's a question mark. So how it works is it means that the last symbol is optional. It's like it could be there or could not be there. So it's easier to if you do this into the capturing group, and you will see that, okay, so now this one is captured, but it's optional. So Sauron is also in the party. Another quantifier we're going to talk about is symbol plus. Plus meaning 1 or more. So you can see that we have matched this one and this one because this one has a lot of symbols, and this quantifier applied to any symbol will match this whole block. There is another one which is an asterisk, which means 0 or more. So in combination, you can say question mark and plus gives you asterisk. So question mark 0 or 1. This one is 1 or more, and this one is 0 or more. There is also another way of achieving that by writing it in a different syntax. You can write the curly braces and say, for example, how many times exactly do you want it to be? Maybe you want it to be once, or maybe you can say 0 or 1. So this one is exactly the question mark syntax, right? You can say 1 or more. That's exactly plus syntax. Or you can say 0 or more. This is exactly the asterisk syntax. Before you decide, cool, I know regular expressions, it is time to use it in production, I must warn you, it often leads to the following situation. We have a problem. Yeah? Let's solve it with regexp. Now we have 2 problems. I will give you a real life example. A lot of the time people decide to use regex to figure out, for example, is this email entered by a user valid? And the problem starts when you start researching what the actual valid email is according to RFC. And you'll find that there's so many edge cases and so many complexity involved that it's very hard for you to write regex. So instead, maybe you want to check very high level the any symbol, any text, @ symbol, and any text, and then try to send the email with the link to activate the account. And now you, my friend, know regular expressions. Good luck and see you next time.